Hey, all you tech enthusiasts, let's talk about something revolutionary: AI kernel drivers. Imagine a world where your computer isn't just a hunk of metal and silicon, but a smart, adaptable machine. That's what AI kernel drivers promise. They act as the brains behind your hardware, constantly learning and tweaking things for peak performance. Traditionally, hardware components like your graphics card or network adapter relied on predefined settings. These settings were often static, meaning they couldn't adjust to changing workloads. But with AI kernel drivers, we're entering a new era of dynamic hardware adaptation. Imagine your graphics card automatically overclocking during a demanding game, or your network buffer adjusting on the fly for smoother streaming. Think of it like this. Imagine driving a car where you couldn't change gears. You'd be stuck crawling uphill and roaring unnecessarily on flat roads. AI kernel drivers are like having an infinitely variable transmission, always optimizing your hardware for the task at hand. This is a game changer, folks. It means our devices can finally break free from the limitations of static configurations and reach their full potential. In the next sections, we'll dive deeper into how traditional hardware configurations work and why this new approach is so revolutionary. Let's rewind a bit and talk about how your computer hardware typically works. Think of your computer like a well-organized factory. Each component, like the CPU, RAM, and GPU, is a separate department with its own specific job. They communicate and share data through channels called buses, which are like conveyor belts moving information around. Now, these departments have fixed capacities, kind of like a factory with a set number of workers and machines. When you buy a graphics card, it comes with predefined settings for things like clock speeds and memory bandwidth. These settings determine how fast the workers in the GPU department can process information. Similarly, your network adapter has fixed buffer sizes, which are like storage bins for incoming and outgoing data packets. These buffer sizes are set during manufacturing and usually remain unchanged. It's like having a fixed number of loading docks too few, and you get bottlenecks, too many, and you're wasting space. This traditional approach has worked for a long time, but it's becoming increasingly inefficient. Our computers are handling more complex tasks than ever, and static hardware configurations can't keep up. In the next section, we'll explore the limitations of this fixed approach and why it's time for a change. Remember those fixed factory settings we talked about? Well, they have a major drawback. They're inflexible. Just like a factory designed for one specific product struggles to adapt to a new one, static hardware configurations can't always handle the changing demands of modern computing. Here's the thing. Our computers are constantly juggling multiple tasks. One minute you're editing a video, the next you're browsing the web with a dozen tabs open, and then you're hopping onto a video call. Each of these tasks requires different levels of processing power, memory bandwidth, and network resources. With fixed hardware settings, your computer is stuck in a single gear. It can't dynamically adjust its resources to match the task at hand. This means you're either left with performance bottlenecks and lag, or you're wasting precious resources when running less demanding applications. Imagine trying to run a marathon with your shoelaces tied together. That's what it's like for your computer with static hardware settings. It's time to cut those laces and unleash the full potential of our devices. This is where AI kernel drivers come in, providing the flexibility and intelligence needed for a truly responsive computing experience. Stay tuned as we explore how they work their magic in the next section. Section 4: AI to the rescue, observing system demands in real time. Now, let's talk about how AI kernel drivers are changing the game. Remember how we compared traditional hardware to a factory with fixed settings? Well, AI kernel drivers are like having a team of brilliant engineers constantly monitoring and optimizing the entire operation in real time. These AI-powered drivers are like the eyes and ears of your system, constantly gathering data about how your hardware is performing. They keep track of things like CPU utilization, memory usage, network traffic, and even the temperature of your components. Think of it like having a team of expert mechanics huddled around your car engine, monitoring every gauge and sensor. They can instantly detect even the slightest change in performance and make adjustments on the fly. This real-time monitoring allows AI kernel drivers to understand exactly how much each component is being pushed at any given moment. They can identify potential bottlenecks before they even occur. and dynamically allocate resources where they're needed most. Section 5, Dynamic Duo Adjusting Buffers and Thresholds on the Fly. Okay, so AI kernel drivers can monitor your system in real time. But what do they do with all that information? This is where things get really interesting. AI kernel drivers have the power to dynamically adjust various hardware parameters, including buffer sizes and performance thresholds, to optimize performance on the fly. Let's go back to our network adapter example. Remember those buffer sizes, the storage bins for data packets? With AI kernel drivers, these buffer sizes aren't fixed. Instead, the AI can constantly monitor network traffic and adjust the buffer size accordingly. If you're downloading a large file, the AI might increase the buffer size to accommodate the influx of data, ensuring a smoother download. But if you're just browsing the web, the AI might reduce the buffer size to free up valuable memory resources. It's like having a warehouse that magically expands and contracts based on the volume of goods being received and shipped out. This dynamic adjustment ensures that resources are always used efficiently, maximizing performance and minimizing waste. Section 6, the future is flexible, potential, and advancements. We've only just scratched the surface of what AI kernel drivers can do. As AI technology continues to advance, we can expect even more impressive capabilities and performance gains. Imagine a future where your laptop automatically adjusts its power consumption and performance profile based on your location, the applications you're using, and even your typing speed. Or picture a gaming PC that dynamically overclocks its GPU and RAM only when needed, reducing power consumption and extending the lifespan of your components. The possibilities are truly endless. AI kernel drivers have the potential to revolutionize the way we interact with our devices, making them more intelligent, efficient, and responsive than ever before. This is just the beginning of a new era in computing, and I, for one, am incredibly excited to see where it takes us.